All right, let's talk about Kubernetes objects. Look, if you really want to get Kubernetes, you have to start right here. Objects are, quite literally, the fundamental building blocks for everything that happens inside your cluster. So here's what we're going to cover. First, we'll hit the big idea behind objects. Then we'll dive into the core logic that makes Kubernetes tick. After that, we'll see how you actually talk to your cluster, break down the language it speaks, and finally, we'll put it all to work. Okay, let's jump right in. We're going to start with the single most important concept in all of Kubernetes, the idea that really drives the entire system. So what is a Kubernetes object? Well, at its core, you can think of it as a saved record. It's kind of like a contract you make with your cluster. It's a file that lives inside Kubernetes and describes exactly what you want to be happening at all times, from the apps you're running to how they can talk to each other. And this quote right here, it perfectly captures the whole philosophy. See, you're not giving Kubernetes a step-by-step list of commands, not at all. Instead, you just declare your end goal, your record of intent. You tell it what you want the world to look like, and then you trust the system to do whatever it takes to make it so. It's a really powerful way of thinking. Okay, so how does this record of intent actually work? Well, it all comes down to this really cool engine that runs Kubernetes, this constant back and forth between what you want and what's actually happening. Okay, check this out. At the heart of pretty much every object, you've got this constant balancing act going on. On one side, you have the spec, that's short for specification. This is where you write down your intent, your desired state. And on the other side, you have the status. That's the cluster's reality. Kubernetes itself is constantly updating this field to report what's actually going on. The main job of Kubernetes? Keep these two in balance. And this right here, this is where the magic happens. It shows you the self-healing power of Kubernetes in action. So let's walk through it. Step 1, you define your spec. You say, I want 3 copies of my app. Step 2, Kubernetes makes it happen. 3 instances spin up. But then, step 3, 1 instance fails. The status changes. Now reality doesn't match your intent anymore. And that's when step 4 kicks in. The system sees the difference and boom, automatically starts a new instance to get back to your desired state. It's always working to make the status match the spec. So that's all great, but how do you actually tell the cluster what you want? You can't just shout at your server room, right? Well, you kind of can in a way. The way you talk to Kubernetes is through its API. And the most common way you're going to do that is with a command line tool called kubectl. What you do is define everything you want in a special file called a manifest, which is pretty much always written in YAML, and then you just hand that file to kubectl to do the talking for you. Okay, let's actually tear one of these manifest files apart. I know they can look a little scary at first glance with all the indentation, but trust me, once you see the basic structure, it all makes perfect sense. Okay, here's the deal. No matter what kind of object you're making, a deployment, a service, anything, the manifest has to have these 4 fields. It's not optional. You've got to tell it the API version you're using, the kind of object it is, some metadata so you can identify it, like a name, and of course, the spec, where you define what you want it to do. So let's look at the first 3 in action. You can see we're telling Kubernetes we want to use the apps/v1 API. The kind of object we're creating is a deployment, and under metadata, we're giving it a unique name, ngix deployment. Simple enough, right? And then we get to the spec. This is the whole point. This is where you declare your intent. For this deployment, we're being very clear. Our desired state is to have 2 identical running pods. We want 2 replicas. And if you dig even deeper inside that spec, you get down to the real nitty-gritty, the actual container definition. Here, we're being super specific, saying that the pods in this deployment should run a container we're calling Nginx, and it should use the official Nginx image version 1.14.2. All right, so we've written our manifest. Now what? Let's see how we actually get this from a text file into a real running application on the cluster. You know, it's actually incredibly simple. It's just one command, kubectl apply. You use the -f flag to say, hey, I've got a file for you, point it to your manifest, and hit enter. That's it. Kubernetes takes it from there and gets to work making your intent a reality. But that begs the question, right? What if you mess something up in the file? A typo, maybe? That's a great question. And yeah, Kubernetes has an answer for that. When you send that file, the API server itself can actually check it for you, catching weird fields or other mistakes before it even tries to do anything. And you actually have some control over this with a flag called -validate. By default, it's set to strict, which means if there's an error, it's going to fail right there. But you could also set it to warn, where I'll tell you about problems but try to apply it anyway. Or if you're feeling bold, you can just tell it to ignore validation altogether. And that's really the core of it all. It comes down to those key ideas. Objects are your intent, the system is always trying to match the status to your spec, and you define it all in a YAML manifest. Once you understand that language, you can ask Kubernetes to build pretty much anything you can dream up.